continue.
From here. Part D, we are finding dx of, in brackets, that's x squared minus x minus 12 all over x squared plus 3x. Again, we do not differentiate before it is in the language that the rules can observe. Factorize the numerator. I have x plus 3 into x minus 4 all over x bracket x plus 3. We close the bracket. This cancels with that. So I have d of x minus 4 over x. That is very, very important. This is equal to d of x over x minus 4 over x. You close. Now this gives us, we're not differentiating. Yes, we are just writing it in a language that we will understand. X divided by x, that's 1 minus 4x to the power minus 1. Please use your exponents. 1 over x is the same as x to the power minus 1. Now we are differentiating. Differentiate a constant, we get a 0. Then minus 1 multiplies minus 4, we get 4. X to the power minus 1 minus 1, that's minus 2. And then this gives us 4 over x squared. We are now taking part E. We want d dx of x cubed minus 2x squared plus root of x all over x squared. Now this one here, all we need to do is to just use the same technique of moving from this state to this state. So this is equal to d dx. We are not differentiating yet. That will be x cubed over x squared minus 2x squared over x squared plus root of x over x squared. That's what we are saying. This is equal to d dx. When you are not differentiating, please don't drop the d dx. We are just simplifying for this expression to be in a form where we can apply the rules. This gives us x. This gives us minus 2. This gives us plus x to the power half over x squared, because we want to show that root of x is x to the power half, which is equal to d dx of x minus 2 half minus 2, that's plus x to the power minus 3 over 2. Now everything is in the form where we are able to apply the rules. To differentiate x, we get 1. Differentiate minus 2, we get 0. Then this comes down. It is going to be minus 3 over 2. Then x to the power minus 3 over 2 minus 1. That's minus 5 over 2. Which then becomes 1 minus 3 over 2 x to the power 5 over 2. We have just taken it down. Remember, when you take the x down, the base down, the power becomes positive. That's exactly what has happened. Our last example in this video will be f, and we are required to differentiate s equal to t to the power half minus 3 into t to the power 3 over 2 plus 2. We are going to multiply. This times this, we get t to the power 2, because it will be 1 plus 3, that's 4 divided by 2, that's 2. This times this, it will be plus 2 to the power 2t to the power half. 3 times that, it will be minus 3t to the power 3 over 2. Minus 3 times 2, that will be minus 6. There are no like terms, so we do our differentiation. So ds dt, please notice it's not dx. This is equal to, the 2 comes down, then t to the power 2 minus 1, we get a t. Here, our half comes down to multiply the 2. Then we're getting 1. Are you noticing that? So it's plus t to the power half minus 1. That's minus half. Then this again comes to multiply that. It will be minus 9 over 2. T to the power 3 over 2 minus 1. We get half. Then differentiate the 6. It's a constant. We get a 0. We are now rewriting this without negative powers. We always write our solutions without negative powers. So it will be 2t plus 1 over t to the power half minus 9 over 2t to the power half. Then that is our answer. Then we now do our classwork. Exercise 6, numbers 5 are 2, 5, 12, 15, 18, and 28. Then your homework, exercise 6, numbers 1, 10, 13, 20, 26, and 27. Thank you very much.